starts like this, but then in the middle, the magnetic field gets wrapped around the sun quite faster. So it gets denser and denser and denser. And at some point, these magnetic fields recombine. That's in those sunspots. So these are points where the magnetic fields are very close together. So it's very, very, very active. And at some point, it just, so to say, breaks up. So this magnetic energy is released and goes into like solar flares into the space. So, but that's actually a really complex process because this wrapping, like this happens over this period of 11 years, and then after all is wrapped up and released, then the magnetic field like is completely shut down, and then it builds up again. So this is like a cycle that goes all over and over and over again.
So it's just the energy. It forms and the tension builds up, it releases, and again it starts. It's a process.
Exactly, yeah. Because of the plasma and that moving magnetic fields, yeah. So in a way, like those those northern lights and sunstorms, or called magnetic cyclones, those are all like the magnetic force because of moving charged particles in the sun.
And what about the lights when you go to the northern lights, those yellow, white, orange, red sky? Why does that happen?
Well, those charged particles from the sun, like protons or electrons, they will travel towards Earth. In the case of northern lights, I mean, it happens all the time, but not only in the direction of Earth. So if we are lucky in a way that this beam of charged particles travels towards Earth, then like he said, Earth also has a magnetic field. So positive charges will be traveling towards the negative north pole of Earth, and positive particles will travel to the opposite one, and then they hit Earth's atmosphere. And when charged particles hit Earth's atmosphere, sometimes they get absorbed, right? And from atoms in the atmosphere, and those atoms in the atmosphere get excited. And then, but they don't want to be excited, so they release photons to get rid of this energy. And depending which particle hits the atoms of the atmosphere, sets like which photon will be released from this atom. And if it's a photon with a certain wavelength, for example, let's take the green wavelength, then you will see green northern lights. If it's a different particle, this will cause a different photon and different molecules to be excited, and it will be a different color. So these are like particles from the sun hitting the atoms of Earth's atmosphere, exciting them, and these atoms will get de-excited, and in this process they release energy by a photon, and that you can see.
That's why those colored,
exactly, yeah.
Different colors of light.
Yeah, so different molecules, different energies. Yeah. Like color represents always energy, right? So reddish color is less energetic than bluish color. So therefore you can see which atom or which particle is actually hitting Earth. Yeah, that's how northern lights are. And sometimes those storms are so strong that you actually can see those northern lights, like they're called northern lights, but actually you can also see them in the South Pole, so southern lights is also the same thing. But sometimes those storms are so strong that because Earth's magnetic field is not only on the South and North Pole, it's all over the place, but it's just the strongest at those poles. But if the solar storm is strong enough, you can actually see that close to the equator also. So there have been some events in the past where northern lights were observed on the equator.
Okay, and which part of which country or which place?
Like usually you will see northern lights only in countries which are close to the magnetic poles, which are, by the way, not exactly like the geographical north and south poles. So the magnetic field of Earth is kind of shifted. So you have North Pole and South Pole geographically, but North and South Pole of the magnetic field of Earth are slightly tilted. Yeah. And this actually changes. Like every 90,000 years or so, the magnetic field completely switches. It happens like in the past of Earth, like many times already. Yeah. But it's